All right, hi guys. We're going to look at number 8 for a speed of sound calculation problem using the guess steps. So this was one of the practice problems. Hopefully you attempted this. This was one of the more difficult ones. Not so difficult for this one in terms of the actual calculation, just a lot of words that you have to kind of sort through. So this problem talks about ultrasonic sound waves. Ultrasonic means that the sound waves have a frequency that's higher than the frequencies that most humans can hear. So our hearing range is from 20 hertz up to 20 kilohertz or 20,000 hertz. In this case, these rodent repellent devices, kind of random, can emit frequencies up to 45 kilohertz or 45,000 hertz. So I'm going to list that as one of my pieces of given information here. So F equals 45. I'm going to rewrite this as 1,000 hertz. Okay, and then the speed of sound is 344 meters per second. So we talked about how speed of sound can change based on the density of the medium it's moving through. We've talked a little bit about the constant of 340 meters per second. In this case, there may be a different temperature of air that the sound wave is moving through. Okay, those are the only values I see. We have units correctly labeled. If I wanted to rewrite the units of hertz, I could relist this as 1/seconds. Okay, in this case it would be sound waves per second. Let's move on to the unknown. It says determine the wavelength of these sound waves. Sounds waves. Whoops, that's an error. Okay, so let's insert wavelength equals question mark. I do not have the symbol for wavelength available, which is lambda, should be an upside down y. So wavelength equals, we use the triangle, we would cover up lambda, and we're left with V over F. And now for our substitute, wavelength equals, plugging in from our given information, 344 meters per second divided by, let's do this, divided by 45,000 1/seconds. So what happens here when we have a fraction in the denominator, when we are going to reduce this fraction, the denominator 1/seconds is going to flip and multiply with the numerator. So if 1/seconds flips, we would have meters per second times seconds over 1. In that case, the seconds would cancel out. We'd be left with meters, which should be the accurate value for our units for wavelength. Wavelength, again, is the distance from crest to crest, trough to trough, or rest point to another rest point before the pattern repeats itself in the wave. So let's go ahead and divide 344 divided by 45,000 is going to give us 0.0076. We'll round there. Final answer, meters. Forgot to change that to 44. Let's double check that. And that would be your final answer. Again, I don't have the lambda symbol available. That would be the upside down y variable to stand for wavelength. Okay, so that's it. I will go through a problem where you're solving for wavelength next.